All right, so these are our notes on page 3 of our Unit 7 packet on chemical reactions. So this is our lesson on just an introduction to chemical reactions and how to write a chemical equation. So we learned back in Unit 2 what a chemical reaction is, but we're going to go into more depth on this. So a chemical reaction is the same as a chemical change. Okay. In a chemical change, atoms are just being rearranged. So in order for them to be rearranged, we have chemical bonds, so like ionic and covalent bonds that are broken, and new bonds are formed. So you're ending with the same materials that you began with, so all the same types and numbers of atoms. They're just in a different, maybe in a different form. So they might be in a different compound, or they might be as individual elements and they started out as part of a compound. So let's review what the evidence is that a chemical reaction is happening. So what will you see if a chemical reaction is occurring? You might see a gas being produced. You might see a precipitate that forms. Let me fix that real quick. Okay, so a precipitate could form. Now, and if you remember, a precipitate is when you have two solutions that react and you get a solid product. Okay? You could have an energy change. So it could make the container that the reaction is taking place in, can make it warmer, colder, so you have a heat, change in heat. You could see light being emitted. You could even hear sound. So, like for example, in an explosion. You could have a odor change. You could have a color change, which often happens with a precipitate. Or a color change is different than color mixing. I'm going to add one more down here. You can have a pH change. So we might have to test for a pH change using some kind of indicator solution or pH paper. Okay. All right, so let's head down here to a chemical equation, what chemical equations are. So chemical equations just help us, it helps describe the reactants and the products of a chemical reaction. When you write a reaction, you're always going to have the reactants on the left side, so that is what is undergoing the change. Then you're going to have the products, which always are on the right side. Okay? That is the result of the chemical reaction. In between, you have this arrow. This is called the yield sign. Okay? So these two sides, the reactants and the products, these are not equal to each other. The reactants react and form the products. Okay? In your chemical equations, we have some requirements. Number one, when you write your formulas for your chemical reactions, the subscripts represent the number of atoms that are in the chemical formula. So, for example, when you write H2O, water always has 2 hydrogen atoms and 1 oxygen atom. You cannot change the subscript right here. You have to use your formula writing rules and write the correct subscripts. For example, if I was writing potassium oxide is always K2O. This potassium's +1, oxygen's -2, and I did my crisscross. Okay, the 2 went here, the 1 out here. So I cannot change these subscripts. Okay, those are determined by our formula writing rules. Our second rule is that we're going to be using something called coefficients. These represent the ratio of molecules or of moles. So molecules would be at a very small scale. Moles is a much bigger scale that's more realistic. And again, reactants are on the left side, products are on the right side. You have to have the correct formulas of your reactants and products. It must satisfy the law of conservation of mass. So this is actually why we use the coefficients. Okay. It says no atoms are created nor destroyed in a chemical reaction. They are only rearranged. So the number and type of atoms are the same on both sides of the equation, which also means that the mass of the reactants must equal the mass of the products, keeping in mind that gases have mass. So if you do a reaction where it is open to the air, the gas could escape into the air and it will look like the mass went down, but it's not actually going down. The gas is being released into the air. So the mass of each element does not change and the total mass does not change. Okay? All right, the symbols that we have in our chemical reactions include the yield sign here. So this is your yield sign. You have your reactants on the left, products on the right. You have your chemical formulas with the little numbers being the subscripts that are part of the chemical formula. And then you have the big numbers out in front, which are the coefficients. Okay? And then you have and signs, the plus signs, if you have more than one reactant or product on either side. So coefficients are your big numbers that are in front of the formulas. Okay? We use these to balance, running into my P there, balance the reactions. Subscripts are your little numbers. They're in the formulas. These are used to write the formulas using our formula writing rules. Okay, so think what we just learned in Unit 6. Okay, so we have to use the correct rules. All right, so the arrow is the yield sign. The plus sign, think and. So if you have more than one reactant or more than one product, if heat is added above the yield sign, you will see a little triangle. A catalyst is added to reactions to help them go faster. So if you think of, like if you have, I don't know, if you have reactant A, they was like coming to the dance, and then you have reactant B, who also is at the dance, sometime they need a help from a catalyst. And that catalyst's job is to be like the matchmaker that helps get A and B closer together. So it's not a part of the reaction, it's not a product, it's just there to help things move along. So we have a variety of catalysts that we could use. One example is potassium iodide, and we would write the formula or the symbol of the catalyst above the arrow. So because potassium iodide could be used as a catalyst, we would write its symbol above the arrow. So anytime you see a symbol above an arrow, that means a catalyst was used to help the reaction go faster. Okay? We'll add in states of matter. So we have solids, liquids, gases, and then AQ stands for aqueous, which just means it is dissolved in water. Okay. So for example, down here, let's try to label this reaction with the different parts of a correctly written chemical equation. So we have reactants here. We have products here. We can see the yield sign. We have arrows, or sorry, we have our plus signs, which are and, because we've got two reactants and we have two products. We have to put the and sign in between it. We can see the little numbers are the subscripts that are part of the formulas. We cannot change those. Those are predetermined by formula writing rules. Then we have big numbers out in front, like this 2, which are the coefficients that help balance the equation to follow the law of conservation of mass. And then we have in here as well the states of matter. So in this case, hydrogen's a gas, magnesium chloride is dissolved in water, it's aqueous. This produces the solid magnesium and a solution of hydrochloric acid, okay, that's dissolved in water. All right, so that is it for just understanding what chemical reactions are and how to write chemical equations.